San Diego, and welcome to the 5 o'clock news. I'm Blake Dunn. Tonight we have two segments on electric fields and magnetic fields. We now go live to Catherine Hawkyard on electric fields.
Thanks, Blake. Everything we see and don't see in our world is made of microscopic things known as atoms. These atoms are subsequently made up of smaller particles known as protons and electrons. Protons and electrons are both particles with charges. These charges can either be positive or negative, where like charges repel and unlike charges attract. This happens because all charges create something around themselves known as an electric field. Electric fields apply forces to other particles around them, but the direction of this force is dependent on whether the charge is creating the electric field and the charge receiving the force is positive or negative. If the charge creating the electric field is positive, the electric field will point radially away from the charge. But if that same charge is negative, the electric field will point radially inward toward its own charge. Now say another, less powerful charge is an electric field. How will it react? If this new charge is positive, the force applied by the electric field will be in the same direction as the field it's in. But if this new charge is negative, the force applied by the field will be opposite the direction of the field. Now a word from our studio sponsors.
Thanks, Catherine. Do you want to learn about a real physical way to use the information you just learned about? Well, one clear use is with electrostatic powder coating. Say you have a metal object or a part that you need to paint and make smooth. One of the most efficient ways to do this is with powder coating. You can powder coat a metal object to give that object the high-quality, durable finish you desire. You need certain tools like a spray gun, which positively charges the particles in a special powder, and a curing oven for when you're done spraying. What you have to do is negatively charge the metal object by connecting a ground, which supplies a near infinite amount of electrons to attract the protons, and then spray it with the positively charged powder. The positive charges in the powder will be attracted to the negative charges of the object, and thus the powder will stick to the object. The curing oven comes next, solidifying the connections between the positive and negative charges. The result is one of high quality that was made possible through the attraction of charges because of the electric fields they give off. So get yours today at Donald's Garage. Now back to the news with Charlie, live at Sarah 310 for information on magnetic fields.
Thank you, Blake. I'll be sure to grab my powder gun today. Now, a magnetic field is a picture that we use as a tool to describe how the magnetic force is distributed in the space around and within something magnetic. The magnetic force is a consequence of the electromagnetic force, one of the four fundamental forces in nature. It occurs whenever objects interact in which there is a charge in motion. Two objects containing charge with the same direction of motion have magnetic attraction force between them. This means that opposites attract. The north side of the magnet will be attracted to another magnet that has its south pole facing it. Magnetic field lines have specific properties. First off, they never cross each other. The magnetic field is strongest when the magnetic field lines are closest together. In addition, they don't stop or start anywhere. They form continuous loops inside the magnet. The field lines point from south to north. However, outside of the magnet, the field lines leave the north pole and enter the south pole. So now that you know the properties of the magnetic field, let's turn to how you measure it. Since the magnetic field is a vector quantity, you have to account for both the magnitude and the direction. Magnetic fields are measured in Teslas and are represented with the symbol B. Now over to Blake with a quick word on Ampere's law.
Thanks, Charlie. Ampere's law allows us to find the total current enclosed by an area bounded by a closed curve that creates a magnetic field around the curve. This formula states that for any closed loop path, the sum of the length of elements times the magnetic field in the direction of the length of the element is equal to permeability times the electric current enclosed in a loop. Since we see the sum, we know we will use an integral. To calculate the direction, you will use the right-hand rule. You will grip your right hand around a straight wire in the direction of current. Curl your fingers around the wire, and that will show you the direction of the magnetic field. Now back to Catherine with how magnetic fields affect your life.
Thanks, Blake. With all this information in mind, we must analyze how this applies to real life. One example of this is the magnetic compass. Earth is like a giant magnetic bar. and since the iron needle is magnetized, it can pivot freely from north to south. This helped mariners find their way when lost at sea. More recently, magnets have been used in car horns as magnetism creates sound vibrations. When a person presses down on a steering wheel, this depresses the iron bar that passes through the electromagnet. The bar moves up and down within the field which produces a sound. Think about that the next time you get mad and honk at the jerk in front of you for cutting you off. Now, over to Charlie with the weather.
We've got some beautiful weather in the North Pole right now. If you're able to look up in the sky, if you happen to be in the neighborhood, you'll be seeing some strange patterns in the sky called the Northern Lights. But why do we see these strange patterns in the sky? Well, the temperature above the surface of the sun is millions of degrees Celsius. At this temperature, collisions between gas molecules are frequent and explosive. Free electrons and protons are thrown from the sun's atmosphere by the rotation of the sun and escape through holes in the magnetic field. Blown towards the Earth by solar wind, the charged particles are largely deflected by the Earth's magnetic field. However, the Earth's magnetic field is weaker at either pole, therefore, some particles enter the Earth's atmosphere and collide with gas particles in our atmosphere. These collisions emit light that we perceive as the dancing lights of the North and South Poles, called the North and Southern Lights. And now back to Blake.
Thanks, Charlie. We hope you learned a lot, and we thank you for tuning into the 5 o'clock news. That's all we have for tonight, so we will see you tomorrow. Stay classy, San Diego.
If you are at the North Pole right now, you might
Charlie,
be able
what'd
to
you
look
get
up.
for number one?
Sorry.